So these are the target 5 notes, and it starts with the question, you played in a basketball game in which you scored a total of 31 points. In the game, you made 3 more 2-point shots than 3-point shots. How many of each type of shot did you make? So for these problems, we're going to be wanting to come up with 2 equations, kind of defining what those variables are that we're using in the equations, and then solving from there. So we already learned substitution and elimination. We're going to be doing some of that today. So I'm just going to say like my x is this and my y is this. I'm going to state that my x are my 2-point shots, and you could state either one. You could say that's x, that's y, whatever you want to call it. I'm going to say this is my x. So my 2-point shots. And then I'm going to say that my y is my 3-point shots. That's just your first step for these. Okay. So then let's talk about the equations that we might have. So I know that it says I scored a total of 31 points, but I don't really know how many shots I made. It says that I made 3 more 2-point shots than I did 3-point shots. How many of each type of shot did I make? Well, that's not really making too much sense to you because it is kind of confusing. What you can do is create a little table, a little x and y table. So if I know that my x's are my 2-point shots, and I made more 2-point shots than I did 3-point shots. Let's see, let's say that I made 10 2-point shots. Well, I made 3 more of those than I did 3-point shots, so I'm just going to subtract 3. So I made 7 3-point shots. 3 more than 7 is 10. So let's say I made 5 2-point shots. I actually only made 2 3-point shots. I'm just subtracting 3 each time. Let's try another one. Let's say I made 20 2-point shots. I made more than that than I did the 3-point shots, so I'm just going to subtract 3 again. And I only made 17 of those 3-point shots. So you can kind of see a pattern starting here. I'm just subtracting 3. I can really just say that I'm adding 3 to my 9s to get my x's. So one of my equations is just going to be y plus 3 equals x. And then my other equation is going to have to do with the amount of points for each shot. So if I know that I'm making 2 points per 2-point shot and 3 points per 3-point shot, I'm going to say that I'm making 2 points for every 2-point shot, and I'm making 3 points for every 3-point shot to get me to that total of 31 points, because I know I made 31 points total. And whenever you see or hear or think of the word per, like 2 points per shot, that's always multiplication, so you can always just tack that on to the front of that variable. So then solving the system, we're going to have to use either substitution or elimination here. You can use either one going through these notes or going through your homework, whichever one you want to use. You're going to have to use both of them on the test or the quiz, so be comfortable with both of them, but you can use your favorite one in this case. I'm going to actually use substitution here. So I'm going to rewrite these equations down here. I have y plus 3 equals x, and then I have 2x plus 3y equals 31. I just rewrote them. So this is actually in really, really good form for me to just use substitution, because it says x equals y plus 3. I can just sub that right in for x here. So that's going to be my first step. So I'm going to go ahead and say 2 times whatever x is, so y plus 3 plus 3y equals 31. So all I did was write in y plus 3 for my x. I just subbed it in there. So then I'm going to go ahead and distribute this and solve. So I get 2y plus 6 plus 3y equals 31. I'm going to combine those y terms to be 5y plus 6 equals 31. When I subtract 6 over, I get 5y equals 25. And then when I divide by 5, I get y equals 5. So here's one of my answers. Well, I can actually just take this now, and sub it back into the beginning. I'm going to use that really simple y plus 3 equals x equation and say that, okay, if I know y is 5, I can just say 5 plus 3 equals x. Well, x has to equal 8 then. All right, so my answer here, and you can write this like this, I made 8 2-point shots because 8 was representing my x was my 2-point shots, and then I made 5 of the 3-point shots. So I'm going to say that. I made 8 2-point shots and 5 3-point shots. This is my final answer. Okay, let's move on to the next one. You are planning a 7-day trip to California. You estimate that it will cost $300 per day in San Diego and $400 per day in Los Angeles. Your total budget for the trip is $2,400. How many days should you spend in each city? So I'm going to go ahead and declare my variables first. I'm going to say one of them is x, one of them is y, and then go from there. So I'm going to go ahead and associate San Diego with my x's. But I'm not just going to say that x represents San Diego. Actually, x is going to represent the days I spend in San Diego. So I'm going to say days in SD, San Diego. And then my y is going to be associated with my Los Angeles. So I'm going to say that the y actually represents the days I'm in Los Angeles. So days in LA. All right, so it's not just the cities, it's actually the days, the amount of days I'm spending in each city. So one of my equations is going to be really simple. It says that I'm planning a 7-day trip. So I know that the amount of days I spend in San Diego plus the amount of days I spend in LA has to equal 7. So one of my equations is just going to be x plus 7. I'm sorry. X plus y equals 7. The days in San Diego plus the days in LA equals 7 days total. And then let's talk about money. So I know that my total budget is $2,400. Well, I know $300 per day in San Diego, $400 per day in Los Angeles. I see that word per, so I know I'm just going to be multiplying here. So I'm going to say if $300 per day in San Diego, it's going to look like this. 300x. $300 per day in San Diego. So just 300 times x. And then $400 in a day in Los Angeles, so 400y equals my total budget of $2,400. All right, so that's my other equation. Now I'm just going to solve the system using substitution or elimination. Okay, so, whoops. I'm going to rewrite my equations. I just like to do that. X plus y equals 7, and then 300x plus 400y equals 2,400. Okay, so I'm actually going to use elimination here just because I haven't used it yet and I know that I need to be comfortable with it in order to be successful on the assessments. So I'm going to go ahead and use elimination. I'm going to multiply this top equation by something in order to get myself able to eliminate something from the bottom. So I'm going to multiply the top by 300. I'm going to get rid of my x's first. So I'm multiplying every term in there by 300. So this actually becomes 300x plus 300y equals 2,100. And then my bottom one just stays the same. 300x plus 400y equals 2,400. Okay, so now that I have my elimination set up, I can actually just go ahead and, whoops, I actually want to do that purple. Subtract that bottom equation from that top equation. So this is going to become 300x minus 300x 300y minus 400y, and then 2100 minus 2400y. So those are going to cancel. That was the whole point. 300y minus 400y is going to get me a minus 100y. And then 2100 minus 2400 is negative 300. All right, so it looks a little funny now, but once I divide by that negative 100, those negative signs are going to go away. So I divide by my negative 100, and I get y equals 3. All right, so one of my answers is already done. Well, if you recall, one of our equations was super simple. I can actually just take this y and plug it right into that first equation there, x plus y equals 7. Well, I don't know my x, I know y is 3, and I know they have to equal 7. So I'm going to subtract 3 from both sides to get x equals 4. All right, so now I can write my answer. So if x equals 4, my x was representing the days in San Diego. I am spending 4 days in San Diego. And 3 days in Los Angeles. I think I spelled that right. Oh, whoops, spelled it wrong. Ah. There we go. All right, so here's our final answer. All right. The next one says that the school theater program is putting on their fall show, and to earn some money for the program, they plan on selling tickets to students and adults. Student tickets will be $3 a piece, and adult tickets will cost $5 a piece. There are a total of 200 seats in the theater. If the theater's goal is to make $700, how many student and adult tickets should they sell? And we need to assume that they would rather sell as many student tickets as possible, even though they make less money off them. So your answer for this one can't just be, oh, well, we'll just sell as many adult tickets as we can to get to 700, because they do want to sell tickets to the students as well. So it's not that easy. So I'm going to go ahead and declare my variables. One is going to be x, one is going to be y. The first thing I see is student tickets. That's just going to be my x. And then adult tickets, just the other thing we're dealing with here, that's going to be my y. Okay, so one of my equations here is actually really simple again, just like my last problem. If I have a total of only 200 seats in the whole theater, that means I can only sell 200 tickets. Well, I don't know how many of each one yet, but I know that added together, the student and the adult tickets have to be 200. So my first equation is just going to be x plus y equals 200. I can't sell any more than that because there's only 200 seats. Now let's talk about price. I know student tickets are $3. Adult tickets are $5. Now, $5 each, $3 each. So $3 per ticket, $5 per ticket. That means I'm going to be doing multiplication again. So my student tickets is represented by my x. They cost $3 a piece, which means 3x. My adult tickets cost $5 a piece, so 5y. And I know that I'm trying to make $700, so I'm going to set that equal to 700. You should always set that equal to your budget or what you're trying to make or whatever it says there. Okay, so now I have to solve, and like I said, you need to be comfortable with both substitution and elimination, but while you're doing the homework and stuff, if you just want to pick the one that's easiest to you, that's totally fine. Whichever is your favorite one. I personally like substitution. I think it's a little easier. So I'm going to go ahead and rewrite these, just like I like to do. X plus y equals 200, and then 3x plus 5y equals 700. Okay, so it's not really set up nicely to do elimination, or I'm sorry, to do substitution right now, but I want to do substitution. So I'm going to go ahead and like manipulate one of these just a little bit. and get it to a substitution version of it. So I'm going to take that first one and subtract y from the left and bring it over to the right. So I'm going to say my new equation there is x equals 200 minus y. Now I have something that's actually equal to x that I can plug in somewhere and do substitution. Well, I'm actually just going to plug it into that second equation. So I know that, let's do green, 3 times x, well I know x is 200 minus y, plus 5y equals 700. I'm going to go ahead and distribute that 3, whoops. So I get 600 minus 3y plus 5y equals 700. When I add those y terms together, I get 2y. So 600 plus 2y equals 700. When I subtract 600 over, I'm actually going to get 100 on the right side. So 2y equals 100. And then my last step would be to just divide by 2, if you can see that. And I get y equals 50 as my answer. Let's put in purple. Okay, so y equals 50 is one of my answers. And then my other answer can just be very simply found by, I know x plus y equals 200. Well, x plus y, which is 50, is equal to 200. When I subtract 50, I get x equals 150. So here's my other answer. Now I can write out my answer in words. So I know I'm actually going to sell 150 student tickets and 50 adult tickets. So they're selling as many student tickets as they possibly can. So 150 student tickets and 50 adult tickets. Okay, last one. One number is 5 less than 2 times the other number, and the difference between the two numbers is 16.6. What are the two numbers? The easiest thing for me to see here, like when I first read this, is the difference between the two numbers is 16.6. I know that when I hear the word difference or read the word difference, I'm going to be working with subtraction. So I know that the difference between them is 16.6. I'm just calling one of those numbers x, the other number y, and I'm just saying x minus y equals 16.6. So I kind of skipped the declaring your variables step here, where you say, okay, well this is x and this is y, but it's not like a lengthy word problem where I'm saying like ticket sales or points. I'm saying that just like one number is x, the other number is y. So you can just skip that step here. So the difference between them, x minus y, is 16.6. And I also know that one number is 5 less than 2 times the other number. Okay, so one number is 5 less than two times the other number. So 5 less, that's just minus 5. It's the easiest thing I see. 5 less. So 5 less than 20 is 15. 5 less than 10 is 5. 5 less than 7 is 2. I'm just subtracting 5. So I'm going to say minus 5. I'm going to start there. And then 2 times the other number. So I'm going to say 2 times this number minus 5 is going to get me that number. Okay, so you might try a couple things first and just kind of like guess and check. But 2 times a number and then minus 5 is going to get me that number. So you kind of have to like logically think through to get your second equation there. Well, this is actually set up really nicely to do substitution. Y equals 2x minus 5. So I'm just going to substitute that right in right there. So x minus y, which is 2x minus 5, equals 16.6. I can't forget that this is technically a minus 1 right here, so when I distribute, I have to distribute that negative sign to both terms. So x minus 2x plus 5 equals 16.6. X minus 2x gets me negative x. I still have my plus 5 equals 16.6. When I subtract 5 over, I get negative x equals 11.6. And then I can just divide by 1 to get rid of that negative sign there. X equals negative 11.6. Here's one of my numbers. All right, so now to get the other number, I'm just going to substitute that back in for that first equation. That very simple one, x minus y equals 16.6. Well, I know that x is negative 11.6, so negative 11.6 minus y equals 16.6. I'm going to go ahead and add 11.6 to both sides. And I get negative y equals 28.2. And then to get rid of that negative sign, I'm just going to divide by negative 1. So I get y equals negative 28.2. And you can even check this on your calculator. That'd be a good way to check your work. Try doing the difference between those two numbers and see if you get 16.6. You will. And then try taking one of those numbers, multiplying it by 2 and subtracting 5, and you'll get the other one. So that's the notes.